Hello everybody, this is Carol speaking. Welcome to our PolyWorks webinar. Actually, it's the last webinar of our series. And today we're talking about how to integrate in-house measurement techniques within PolyWorks Inspector. And let's welcome Roberto Barreto, as he is our presenter today. Roberto is a member of the technical support group, and he is now our webinar coordinator. And let me remind you that if you have any questions during the webinar, please use our questions panel. I will be monitoring the questions throughout the webinar, and we will have a short Q&A session at the end. If you don't have time to answer all of the questions, we'll get back to you by email. And actually, guys, I have a favor to ask of you this morning. Do you have suggestions for us, so topics you would like us to cover in a webinar? So please send your feedback to the questions panel. That would be great. Thank you. And as usual, we are recording this webinar, so yes, it will be available for later viewing. So Roberto, it's all yours.
Thank you, Carol. When facing complex metrology challenges, in-house measurement techniques are often developed to achieve the desired results. These techniques sometimes involve repetitive manual operations, which can be time-consuming and could lead to mistakes along the way. This webinar will present how to standardize such methods so that they can be shared with colleagues, reused in different scenarios, and integrated into multi-piece inspection routines. Let's begin the webinar by imagining we are part of a metrology group that specializes in inspecting plastic trims from car interiors. In that scenario, many of the parts we will inspect will contain locating pins for which the center point needs to be measured. This is a very important measurement since we need to make sure that the pin will fit into the rectangular opening in this orange panel so that the assembly can be completed with a clip. Now, the engineering drawing of such panels normally controls a hypothetical rectangular opening which can be reduced to a center point measurement. The problem is that it will take several planes and constructions to obtain the center point from the gray panel CAD model. And even if we don't mind creating all those for each pin, we will quickly realize that the extraction of each one of those narrow planes used is very unstable, and that probing them accurately is pretty much impossible. So instead of doing that, we're going to use an alternate method that's better adapted to such a specific measurement. Here we have a project where we have three clips for which, or three pins for which the center point needs to be measured. And to explain the method that we're going to use to measure them in this scenario, let's first take a look at a traditional feature like a circle. Here we can see that we have already extracted the measure component for the circle from the scan data, and that it is currently deviated along all three axes. If we create an alignment using only the circle, in this case a best fit measurement object, we will see that the deviation along all of the three axes disappears as expected. So what if, instead of trying to extract the measure component for the clip centers, we simply align the clips one at a time using only their surrounding surfaces and make the clip centers have zero deviation once aligned, like the circle does in this particular scenario. To do just that, let's take a look at clip center 1, and for that I have created a surface feature that is using the reference elements of the pin. To measure that surface feature, I will extract it using a feature extraction group. This will make sure to do a local best fit before extracting the measure component of the surface feature. And once this is done, we can now proceed to the alignment of the surface feature using the same technique as before. The alignment is now done, so we know that at this point the clip center should have a zero deviation, so we can define its measure component by using the same coordinates as the nominal clip center. And we can do that by dragging it from the nominal primitive in the tree into our dialog zone and into our point coordinates. So we can see in the annotation now that this does what we wanted, which is getting a zero deviation for the clip center And there's a final step that needs to be done so that that feature point that we just defined is affected by any future alignments. We need to make sure we associate that feature point with the scan data, which we can do by selecting both the primitive and the scan data object and using the align menu to add the primitive to the scan data object transformation group. Once we have done that, if we return to our original inspection alignment, which was best fit to reference 1, we're going to see what the deviation is for that clip center. Now, if I just needed to finish this part, all I would need to do is repeat the same process for the remaining 2 clips. However, being part of a metrology group that inspects plastic trims, I probably will have to inspect similar parts that also have centering clips in the future. So instead of repeating these steps manually every time, I should look into creating a macro script to quickly do these steps when needed. And creating a macro script could be an acceptable solution. But if this macro script is to be used, for example, in production or by many different inspectors in different areas, then the script will need to account for a wide range of user inputs. And at some point, it will end up replacing rather than supplementing existing PolyWorks tools, like, for example, plane inspection. This is where the new scripted measurement methods become so powerful. Rather than manually executing a macro for each one of the clip centers that we have, we can simply go into the properties of those clip centers and specify that they need to be measured using a script. Much like we're used to saying that they need to be extracted, probe, or CNC probe. In my case, I don't have any scripts available at the moment, so I will click on More to go into our macro script management window. And here we see that there are some scripts already available for some commonly used measurement methods. And this comes already with your PolyWorks installation of the 2019 version. But in my case, I will browse for a script that I specifically created for our in-house clip measurement strategy. I will import that from my computer, and we see here that the macros, or the measurement script macros, use a PWX macro extension, which contains the script, but it also will contain a list of parameters and variables that can be used by the macro. Let's import it, and we will see that in this particular macro, there's 3 parameters, such as max distance, boundary exclusion distance, and max angle. And it also contains default values for those parameters. The presence of these parameters will allow me to reuse the script in different scenarios in the future by simply editing the parameters as needed based on the type of clip that I'm extracting at the moment. So once I have imported my script, I can simply go back and assign the method as the measurement method for the 3 clip center points. And now that I've done that, I can launch their measurement like we would normally do from the right-click menu. At this point, the macro gets executed for all 3 clip centers, and I have a result for the deviation along all the different axes. Now, I'm going to clean up my project a little bit by deleting some of the alignments that I used for demonstrating purposes before, and I'm now going to focus on reporting those deviations for those clip centers. So let me start by hiding my scan, and I'm now going to show the deviation for the clip centers. Note that in this case, we are using the primitive center points deviation type, which is very useful in this scenario because it will create an arrow from the measure to the, or from the nominal to the measure primitive, and it's going to do it along the control directions that I assigned to each one of the clips. So, now that I have added those windows there, I'm just going to go ahead and do a nice control view based on the visible objects in the 3D scene. I use my button right here, and I will name that control view the clip center control view, and make sure to create a report item, so I already create a report as well. We'll look at our report. Now we have a full page dedicated at showing our clip center deviations, And in this case, we see we have issues with clip center 1 and clip center 2. Now, I can save my completed project. And to repeat this inspection, all I have to do is click on New Piece. I'll load my second scan in this case. And because my macro scripts are embedded in the project and were assigned to the point features of the measurement method, there is no need for special instructions or manual operations to measure the pins successfully on my second piece. Plane inspection behaves intuitively, and the required macros are executed at the correct locations in the sequence. But that is not all. Scripted measurement methods can also be very helpful with interactive measurement methods, like the probing of features, for example. In this second scenario, let's imagine that we are part of a jig building team and that we regularly need to verify some key dimensions on our built fixtures, like the ones present in this project. The dimensions that I'm talking about are the coordinates of each one of those feature points that you see there, as well as some distances between them. If we take a closer look at one of our points, you will see that all of them are located at the theoretical corner of the fixture pillars. So normally, in order to measure the location of that specific point, I will need to create planes on the fixture faces, 3 of them in this case, and intersect them to get my feature point, for a grand total of 4 features for each corner, and likely some confusion for the operators, which will need to make sure to probe the planes in the right order every time when they're repeating this inspection. So instead of doing that, let's go back to our control points, and once more go into the properties of that feature point. And we're going to try to use a script to measure it in this particular scenario. Once again, there are no scripts available, so I will go into the More section. And here we're going to see that one of the available methods is called probe point from corner. And if we read the description on the right, we can see that it does exactly what we want, which is probe 3 planes and get the measure point from the intersection of those 3 planes. So to make the macro available from the list of scripts in the object, I will simply need to add it to my favorites by clicking on the star icon. Once that is done, I can close out of that and assign the method to feature point 1, and then simply launch the measurement from the right-click menu. At this point, all I need to do is go ahead and measure the planes, and you will see that I'm on purpose doing it in a different order so that you can see that the order really doesn't matter. In that case, the operator is only instructed to measure the 3 planes that relate to feature point 1. And once the 3 planes are measured, with as many points as the operator will want, we are going to get a measure coordinate for that feature point, and more importantly, no construction features in my tree view. So all I get is the measure coordinate that I want without any additional objects being added to my project, which is going to make for a much cleaner project in the end. All I will need to do then to finish this particular project is select the remaining feature points. And even though I haven't assigned them a measurement method yet, I can access the list of scripted methods from the other measurement methods list and launch the probe point from corner method. And at that point, all I will need to do is grab my probe and start measuring the faces.
Thank you, Roberto. So we have a few questions that are coming in. The very first one. So I have existing macros. Is it possible to use them?
Yes. So I mentioned that the macros use slightly different extension, but if we go into the list of more, I'm just going to look for a different macro here on my computer. I have a bunch of macros that I already use for several different things. So all you'll have to do is use your traditional macro there and import it in. it's not going to have any parameters associated to it, so you could add some parameters to it there if you want to, but it should be able. Some restrictions will apply to what the macros can and cannot do, but if you have a macro that already does something similar as what we've done, which is a custom way of measuring a specific object and ending up with a measure component for it, you should be able to use it.
Perfect. Okay, second question here. Now that I have my scripted methods, how can I share them with colleagues?
All right, so sharing them with colleagues is actually very simple. First of all, you could, one simple way of doing it will be to send them your PWX macros, which then will allow them to import them into their programs. But also note that the macros can also be stored as part of your user configuration. So what that means is if you have a nice list of all of many different macros that you've been using, you can share your user configuration with your colleagues, and then they will get all of the list as well. And finally, and this is probably the nicest thing, is if you use measurement scripts in a project by assigning them, for example, like in my case, I use pro point from corner for all of my feature points. Those are embedded in the project. So if you were to send a project to a supplier or to a colleague, he wouldn't even know that he's using a custom method, but he will get those methods as part of the project as well.
Okay, and we have time for one last question. So if you already have existing macros and you don't have the parameters, could you add those?
Yes, so I'm just going to show you quickly. I'm going to go back to the macro management window, which, by the way, you can also access from the search window right here. And for any existing macros, let me just load again the one that we were using for the webinar. So I have 4 macros there, 4 parameters there that were being used. I can add any new parameters from here. So I will need to name it, and the naming can be important because users can, the users are going to see the parameters as measurement parameters in the properties of an object. So if I name this new parameter, and I give it, I say it's supposed to be an integer value, and I give it a default value, this parameter will now be available from the script itself. Just to show you here, the variables can be read using the $number sign, which is the same thing we see here. So that number 5, $number 5 will be available from the list. And more importantly, as I said, when users go to the properties of the objects that are using scripts, they're going to see the list of parameters here, and they're going to be able to easily change it as they would normally do with standard parameters.
Thank you, Roberto. And this is all the time that we have for the questions this morning. So this webinar has been recorded. It will be available on the Innovametrics software website. Navigate to the support section. It will also be available on the Innovametrics software channel on YouTube. Now, our next webinar, well, you'll have to stay tuned. We are going on a summer break. We'll be back in September 12th, in fact. The details for the webinars will be announced through our website sometime during this summer. So thank you for joining us this morning. Take care, and we'll see you next time. Bye-bye, everybody.